Okay, these are the section 3 notes from chapter 9. We start off in class asking a random sample of 15 students how much sleep they got last night. And I am just going to make up data right now, which no is not what you should do. Okay, you know what? I'll take the data from A Day. We had 7, 8, 5, 7, 7, 6, 8, 8, 5, 5, 4, 6, 8, 5, 8. Now the assumptions and conditions are just like they were for interval. So if at any point during the interval you realized if they're giving me numbers, I need to put them in a list in my calculator, sometimes it's helpful to do that right away so you don't forget about it. So I'm going to go into my list right now and put those numbers in, which hopefully, yep, I still have them in there. So go into your list, put those numbers in, double check, and make sure you have the right amount. As there are times where you will forget a number and then you'll have a wrong answer and you won't know why. So they're in my L1. Now I'm going to go back to the actual problem. First step for the state is I have to define the parameter. Look back up into the problem, ask yourself, am I talking about means or proportions? This is a hint right here. This is mu, which is the population mean. So I want to know the average number of hours of sleep of all South River High School students, because that's my population. Then I get to state my null hypothesis and the alternative. Since I've written out in words the parameter for the population, I don't have to do that again. I'm thinking that they should get, on average, 8 hours. For teenagers, I think you're actually supposed to get 9 to 10, but we'll stick with 8. The alternative is that I'm thinking it's less than 8. So, state's good. Would get an E for that. Good job. Plan. Write the assumptions and check the conditions. These are the exact same as they were for the confidence interval for a one sample mean. So, for number 1, it says that I took a simple random sample of 15 students. Well, 8A students didn't think that my sampling technique was really random. So, I could say that the 15 students are less than 10% of all South River High School students, which means my sample is small enough so it's okay to continue. The problem is that my sample size is equal to 15, which is less than 30. So I need to look at the graph of the data, because right now this condition isn't met. So I already have my numbers in the list. I need to look at a graph. Some of you prefer the histogram, others of you prefer the box plot. It really doesn't matter which one. Right now I have the histogram selected, and I'm going to zoom 9 to start. Is it unimodal? Yeah. Roughly symmetric? Well, some of you might argue that. I could always play with the window. That's the beauty in statistics, is we manipulate things until they look good for how we want them to look. I could count by 4s, go from 0 to, I don't know, maybe it needs to go up to 12, and count by 1s. Let's see what that looks like. Okay, definitely unimodal now. Is it symmetric? I don't know. Not really. But there's no outliers. Well, are there outliers? I don't know. We could check with a box plot instead. And zoom 9 again. Wow, check that out. There's no max. Well, there is. The Q3 and the max are the same. Probably would have been helpful if somebody would have said 9 hours, but we didn't have that in our data, so this is real life. There's no outliers though, and that's a good thing. So I am going to copy that graph down. And for my labels, I'm going to hit trace on my calculator. And if I just arrow along, I can see the values down below, and it tells me the 5-number summary. So then I'm going to label my plot above so that anyone can look at my paper and know what my box plot is showing. I could, if I really wanted to, look at the histogram of the last one that I had and copy that down as well if I'm not happy with the one graph. I mean, I have like 12 minutes to answer this question, and that's a lot of time. So let me switch it real quick. Histogram, window, what I have it at 0 to 12, counted by 4s, graph. There it is. And I can hit trace, and it will also tell me my values, and that there are 10 from 4 to 8 and 5 from 8 to 12. So now, since I did the histogram, I could say hours of sleep are unimodal. And with the box plot, I can say none of the hours are outliers. So that checks off my second condition. Notice I threw the word hours in there. That checks off my context part. If you don't put the context, your grade has to get knocked down from an E to a P. Not good. Then make sure that you say with conditions met, we can apply the t-distribution and do a t-test for a one sample mean. Alright, so that's the plan. I have 2 E's so far. Moving on, and 2 more to go. There's a little note here reminding you when to use t-procedures. If it's less than, if your sample size is less than 15, don't use t-procedures if the histogram or box plot shows severe skewness. We had 15, and there wasn't severe skewness. Severe skewness usually means there's outliers. Outliers in one direction, meaning they're either high or low, not both direction, because then it's not really skewed, it's symmetric just with outliers. If the sample size is at least 15 but less than 30, you should only use t-procedures if the data is unimodal and reasonably symmetric. For those of you that are perfectionists out there, you gotta let it go. Statistics is a way of manipulating things into what we want them to be. If the sample size is at least 30, you can use t-procedures. Heck, if it's more than 30, you technically could use z. But we're not going to, because that'll get too confusing for some of you. After the assumptions and conditions are checked, you should write with the assumptions met. We can apply the t-distribution model and conduct a t-test. We already did this on the other page for one sample mean. This is telling the person grading your paper that yes, I know what distribution I'm going to use and why I just checked those conditions. And then you conduct the t-test. We go into the calculator. We already have the data in L1. So we're going to go into stat, test, t-tests, and some of STEM Gym are walking by right now, so if it gets hard to hear me, that's why. It's mostly you guys walking by being loud. Oop, there's Erin. I needed to talk to Erin. She has to make up her testo. All right, the mean of the population was 8. Our data are in L1. I'm thinking that the average hours of sleep is less than 8, and I'm going to calculate. There we go. I've got my t-score, p-value, the mean, sample mean, and the sample standard deviation. So formula-wise, for those of you that love the formula, this is going to be a t-score. Your statistic is x bar minus mu over your standard deviation divided by the square root of n. Notice this little side note, if you have sigma, then you find the z-score. If you only have the standard deviation of your sample, then you have to find the t-score. That's the big difference there. So x bar was 6.467 minus 8 divided by, I'm just plugging in what the calculator told me, 1.407 divided by the square root of 15. Now, of course, if you're not a formula lover, you would just list all this information and say that t is equal to negative 4.219. The p-value it gives us is 0.0004. And remember, if you're to draw that curve, that means that our actual x bar was 6.467. Here's 8. And your t-score is the number of standard deviations away from the mean. And this is your p-value down here, 0.004. All right, conclude. Obviously that p-value is small. So the p-value is less than 0.05, we're going to reject the null. Since the p-value is low, and if you want, you can plug in what it equals right here. P-value equals 0.0004, we will reject the null hypothesis because the p-value is lower than alpha equal to 0.05. Then we have to state our conclusion in the context of the problem. We do have enough evidence to state that Ms. Floshek's students are getting less than 8 hours of sleep a night on average, so you guys need to make sure you go to bed by a decent time tonight. The big part, this would be like part B on your question. Interpreting your p-value. If the null is true, then there's approximately a, in this case, 0.04% chance of obtaining an average of 6.5 hours of sleep in a simple random sample of 15 students. So hopefully that part makes sense. I'm going to continue on. Look at the back. Here's our little template of confidence interval, hypothesis tests, the assumptions and the conditions, and what you want to say, the different names. Of course, in the calculator, it's just t-interval and t-test. Pretty much just fill in the blank. But on the back side, we have another example. We have a coffee vending machine dispenses coffee into a paper cup. You're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. Here are the amounts measured in a random sample of 20 cups. Is there evidence that the machine is shortchanging customers? So once again, look, there's numbers and a list. Put them in the list. Put into list. And then if some of you are those that need structure organization, this is your 4-step process. It's not going to tell you that on the quiz or test, but You could write down for yourself, state, plan, do, conclude. Now I notice some of you are abbreviating, putting SPDC, and that's fine because technically you don't get points for writing these things down. It's just to give you structure so you remember how your paper is going to be scored, because it's going to be broken down into these 4 parts. And if you blow it on the plan, that's okay. You can still get a 3 out of 4 if you hit the other 3. So the state, we need mu. Mu is supposed to be, let's go back to the problem. You're supposed to get 10 ounces of coffee, but the amount varies. Here the amount's measured in a random sample. So it's going to be the average number of ounces, average amount in ounces of coffee. In all cups in the vending machine. There's more people walking by right now if you hear noise in the background. So the HO is mu equals, go back up to the problem, it said it was supposed to be 10. So mu equals 10. And customers are being concerned that they're getting shortchanged, that they're not getting enough coffee in their cup. So your HA is mu is less than 10. Now the plan. Do we have a simple random sample? Yeah, it told us we had a random sample of 20 cups. So we have a random sample of 20 cups. Second one, this is where we have all that data. We have 20, n equals 20. That's not at least 30, so we have to make a graph. Less than 30. So I'm going to go to the calculator and start putting all these numbers in. You should do the same. I'm recording through this. In case you were wondering. I'm going to put them in L2 because I still have values from the notes that I recorded earlier. So I've got 9.9, 9.7, 10, 10.1. Oops, make sure you type correctly. 9.9, 9.6, 9. I know you guys are faster at typing than I am. And look, I'm messing up. Think of this as texting races. 10, 9.5, 9.7, 10.1, 9.9, 9.6, 10.2, 9.8, 10, 9.9, oops, 9.5, and 9.9. Double check and make sure you're got 20 numbers in there. We do. So now I gotta make a graph. Second y equals, change it to L2 and zoom 9. Wow, that looks pretty roughly symmetric. Hey Arthur.
Yeah.
Is that roughly symmetric? Reasonably symmetric. Arthur agrees. He's still here after school. Such a diligent student, working hard. How many of you are after school working hard today? I'm going to hit trace to cheat and quickly copy down my graph. I have a min of 9.5, so that's where I'm going to start it. And it goes up to 10.34. It doesn't matter that they're ugly numbers. That's not a big deal. So I've got 9.5 and I'm going up to 10.34. Now some of you, I understand, like the box plot better because it's easier to copy down. I tend to agree. But this one shows that it's unimodal because you can't talk about something being unimodal in a box plot. And this is a sample size of 1. If I go back, I have a 2. I might need to shut the door. They're having a meeting outside. I don't know what's going on out there. 8. Oh, thank you, Mr. Don. He's shutting the door. 2 and 4. That's good enough. We don't need to make a perfect graph. It's a quick sketch. So remember context. The coffee amounts are unimodal, meaning one peak. If you forget that word, just write one peak. And roughly symmetric. And then we say with conditions met, we can apply the t-distribution. Don't say normal, you get this whole thing wrong. It'll be horrible, all this work. And do a t-test for one sample mean. Now, since you worked so hard, let the calculator do the rest of the work at this point. Go to the calculator, hit stat, go over to test, go down to t-test. We have data. We're told that the machine's supposed to give us 10 ounces of coffee. Our data is in L2, and we're thinking we're getting shortchanged, so we want that middle one that is less than what the population parameter says. Calculate, and there we go. We have a t-score of negative 3.49, which means it's that many standard deviations below the average of 10, and our p-value is 0.001, which, yes, that's low. So we do have evidence that the machine is shortchanging us. We should send it back to the vendor and say we want our money back. So we just copy down all the stuff, negative 3.49, p-value equals 0.001, x bar. Now I know you formula lovers out there want to plug in the numbers, that's fine. And S sub x equals 0.19. Hey, 1986, that was a good year. So draw your picture because the calculator can do it for you. Little tiny spot over here. X bar is 9.845. So technically, really, that's supposed to have 10 ounces in it, and you're getting 9.845 ounces on average. Really, isn't that close enough to 10? Well, according to our test, no, it's not. Your p-value is really small, 0.001. And that there's only a 0.1% chance of us getting an average of 9.845 ounces in a cup if the null is true. So, with a low p-value of 0.001, which is lower than alpha equal to, that's a bad alpha, 0.05, we can reject the HO. We have evidence that the machine is shortchanging customers, I suppose, is dispensing less than 10 ounces of coffee on average. Period. Done. Yay! Good job.